The instrument that we are presenting today, it's called micro X-ray fluorescence, and actually if I just describe with few words what we have here is the possibility of getting X-ray fluorescence with partial resolution. That means we are able to determine the two-dimensional distribution of elements on a sample. And actually the interesting thing on that is that there is no one special application, but you have a variety of application and fields where you can use that. Actually everywhere where you have non-homogeneous materials that you want to study, it's a good place where you can use them for. You can look for geology, forensic application, industrial applications, university research, material science, whatever kind of actually industry or application that requires to determine the distribution of elements in large samples, because that's one of the specialties of this instrument, that you can determine very fast the element distribution without any sample preparation. This is the instrument you're looking for. One of the main features of the instrument was actually based on trying to be able to provide a chamber size and dimension that allows to have access to very large samples. So one of the main features is a very large chamber that is really allowing you to position samples up to 5 kilograms and 30 centimeters long. That's one of the size point. Then we have a very unique option is the possibility to increase the speed of the instrument, because our keys are speed and size. We have the possibility to include two detectors so that we are able to measure parallel using two detectors and two signal processor units and speed the time or speed the acquisition time and the amount of data we get per time unit. This allows us to get really very large areas measured in very, very short time. You can summarize this in two words actually. One is speed and the other one is size of samples that you can handle with this instrument. And actually these two are in all the development that were put in this instrument, including the possibility of having two detectors and the possibility of having a very fast table to move heavy large samples, and also a data processing system that allow us to have a very short acquisition time per spectrum. The M4 Tornado actually, and let me just go a little bit backward in time, I have been involved from an application point of view with the M4 since the beginning. Now we have more than 4 or 5 years of being working on the instrument. I have seen a development and introduction of the instrument in many, many fields. And actually it's very difficult to give one key field where we have seen the instrument going more and more, but it's spreading over many, many application directions. We see that in museums where it measures manuscript, where it measures jewels. We have seen in electronic companies, industry, where they test the quality of their electronic components. We see that in oil companies, where they look, for example, of the distribution of element in drill cores and thin section samples. We have seen in forensic labs, where they look at any type of materials in a non-destructive approach. Actually, the variety of application is huge, and in principle, from my experience, what the application point is, anytime you are dealing with understanding non-homogeneous materials, that's actually the instrument that offers a lot of possibilities of understanding complex modern materials.